Hello students, now let us take the next topic in relations and functions, and that is types of functions. Let us discuss different types of functions here, but before we go forward, let us revise what is a function. A function is something which does a specific activity. We have discussed some functions in class 11, mod x function, x square function, and lot of other functions. For all of these functions, there is a specific input and the function does a specific activity on that input and it gives you an output. Let us say the input is 2 for x square function. Then what is the output? Output is 2 square, that is 4, right? So the related things of a function, all of them, let us understand all of them by taking a very general example. Okay? Now let us take a function. This function for which the inputs is an animal and the output is where it stays. So that is what this function is doing. It is taking the input as an animal and it is giving an output of where this animal stays. To understand this, let us take two sets, set A and set B. Let us say our function is mapping from A to B. Right? So now A will have input elements and B is where you will find the outputs. Now let us take some elements. A has pet dog, lion and whale, and B has kennel, grasslands, sea and trees. Now what are we doing here? We are taking elements which are there in set A as input. So if pet dog is the input for this function, what does this function do? It will map to where it stays. So pet dog stays in kennel. So therefore pet dog is mapped to kennel, lion is mapped to grasslands, whale is mapped to sea. Right? Now for this function, A is playing the role of input set. So A has a specific name to it, and that is domain of this function. Whatever is the set that is providing the input for this function, this input set is called domain of the function. And this function is mapping from A to B. So this B set also has a specific name and that is called codomain of this function. So we have discussed what is the domain of this function, what is codomain of this function. There is one single terminology after this, and that is what is range of a function. Very simple. Range is a set and that set will contain outputs of this function. So for this function, what is the outputs? Outputs are nothing but kennel, grasslands and sea. So therefore, taking all of these elements in one set is called range of this function. So we have understood what is domain of the function, what is codomain of a function, what is range of a function. And after this, we have to understand one small thing. Let us go ahead with it. Let us take what is the mapping that is happening. Here, pet dog is being mapped to kennel, right? So there are small names here which we have to understand. This kennel is called image of pet dog and pet dog is pre-image of kennel. So in the same way, in other mappings also, wherever you have the mapping, the first one is pre-image of the second one and the second one is the image of the first one. So here, if you are taking lion is mapped to grassland, so grassland is image of lion and lion is pre-image of grassland. In the same way, whale and sea as well. So now we have understood what is domain, codomain, range, pre-image and image as well. Now let us understand one more point, and that is a function is a special type of relation. This we have already studied in class 11. What is the meaning of this? What is the speciality of the function? Let us understand. In relation also there is a condition, isn't it? Every relation has a condition. Based on the condition, you will take some ordered pairs from the Cartesian product into our relation. In the same way, in function also we have a condition. In the example that we have taken just before, the condition was if you give an input, then it should be mapped to place where it stays. So that is the condition. So even in relation, we have a condition. Even in function, we have a condition. But the difference is, as far as function is concerned, every element of domain should have one and only one image. Let us take back the set diagram that we have discussed before. Now here you can see every element of our domain has one and only one image. Means every element of our domain has only one arrow coming out of it. So therefore, this is a function. Of course, this is a relation. The ordered pairs coming because of this mapping are subset of Cartesian product. But this relation is also a function because every element of domain has one and only one image. Now let us take a mathematical example. Let's say f is mapping from set A to set B. Let us take some elements in set A and they are 1, 2 and 3. Elements in set B are 3, 5, 7 and 9. Let us say f of x is equal to 2x plus 1. Now what is f of x doing? If you give an input x, then it will double it and add 1 to it, right? So now here, if 1 is the input, then what will it do? It will double it, add 1 to it. So therefore, 1 will be mapped to 3, 2 will be mapped to 5, 3 will be mapped to 7, correct? Okay, so now let us move this diagram little away and let us take some questions. The first question is this f a function? How do you decide? Let us look at the domain. Every element of domain should have one and only one image. And here we can clearly see that every element of domain is having one and only one arrow coming out of it. So therefore, this is a function. Next question, what is the domain of this function? Domain of the function is input providing set, and that is set A. So therefore, domain is equal to set A. What is the codomain of this function? F is mapping from A to B. So therefore, codomain will be second set, and that is set B. So therefore, codomain is set B. What is range of this function? Range is nothing but set of output values. So here the output values of these function are 3, 5 and 7. So therefore, let us write in one set. So this is the range of this function. Next is for 1, what is the image? Image of 1 is 3. So therefore, 3 is the image of 1 and 1 is the pre-image of 3. Okay? Okay, so till now we have understood what is a function, what is the condition that a relation is a function. The condition is every element of domain should have one and only one image. Or we have also studied in this way also, that is every element of domain should have only one arrow coming out of it if you are seeing it in the mapping diagram. And in general, every element of domain should have one and only one image. Means what? Means if you have an input, then for this input, the function should give only one output. For one input, there is only one output. So if you are taking, like we have taken a mathematical example, f of 1 is equal to 3. So if you are giving one input, then the output is also one single, that is 3, right? So we are very clear with what is a function. Now let us understand the same thing graphically. Whenever you see a graph, you should decide if this is a function or not. Okay, so before even coming to this, let us see a graph. Now, is this graph a graph of a function? Means what? Are there graphs which are not functions? Yes, But for now, let us focus on this one. Is this graph a function? Is this representing a function? Now, how do you check? Every element of domain should have one and only one image. What will domain contain? Input values. So just before we have seen, if you are giving one input value, then you should get one output value. Correct? So therefore, for one value of x, you should have only one value of y. Okay. So that is what is written here. But let us check it like this. One value of x. What is the meaning of one value of x? Now let us say, for example, you choose this value of x. This is 5. Now, wherever you go on this line, which is parallel to y-axis, passing through 5 on x-axis, x is equal to 5 only, right? Okay. So, wherever you go on this line, x is equal to 5. Of course, y coordinate is changing. So, if it is here 5 comma 0, if it is somewhere little up, then it will be 5 comma something. If you are going down, 5 comma some negative number. Now, so this is the place where x is equal to 5. Now, for x is equal to 5, there should be only one output value for the function. Means what? There should be only one place where this line cuts the graph. Okay. Let us say, for example, this graph is something like this. Now, for x is equal to 5, this graph is saying that there are two values which come out. That is, let us say, for example, this is 10 and this is 15. So, for x is equal to 5, y coordinate is 10, and for x is equal to 5, y coordinate is also 15. So, therefore, then it will not be a function. Now, let us come back. So, here, if we are taking one specific x value, then there is only one y coordinate. Okay. Now, we were saying in the definition of the function that every element of domain should have one image. Every element of domain. So, therefore, it is not sufficient if it is happening only at x is equal to 5. Now you have to move this line. Okay. Now here, at how many places is it cutting the graph? Only once. At this one, at this place. At this place, if you are taking this x coordinate, okay, when you are taking the line here, that means you are taking one specific x coordinate. For this x coordinate, how many corresponding y values are there? Only one. No problem. So come here, only one. See, whenever you are leaving the graph like this, okay, whenever you are leaving the graph like this, okay, just like this, means the graph is not only this much, as you go towards infinity, the graph is maintaining the same, a pattern. So therefore, as you go towards minus infinity, it is following the same pattern. So therefore, whenever you leave the graph like this, that does not mean it is ending here. That means it is continuing like this in both the sides. Okay. So basically, now we have understood. You take any specific x coordinate, correspondingly, there is only one y value. Never there is more than one y value. That means this is a function. We are checking the same thing as before in mathematical example. We have seen the, f of x is equal to 2x plus 1. There also, there was one question. Is this a function? How did we check? Every element of domain, is it having one and only one image? Here also we are doing the same thing. Every element means wherever you take the x value, how many places it is cutting means how many places the graph is cutting the line. Or you can say it like this as well. Wherever you take one specific x value, how many y values are coming? Here you can see wherever you take the x value, for that there is only one y value. So therefore, this is a function. Clear? Okay. So this is a graph of function. This is a graph of function. Next, let us come here. Now, as I told you, whenever you leave the graph like this, that means it is going like this, on the positive side and on the negative side also. Okay. Now, what is this saying? Any line parallel to y-axis can cut the graph at most once. Okay. Means if you are taking a line which is parallel to y-axis, it is having one single x coordinate. For this x coordinate, there cannot be more than one y coordinates. Just before we have done the same thing. That is what we are writing as a rule. Okay. This is what you should be checking to see if the graph is graph of a function or it is something else. Okay. Fine. Something else means it is not a function. That's all. Okay. So here, is this graph of a function? Yes. Because you take any line parallel to y-axis, it will never cut the graph more than once. Very good. So therefore, this is also a function. This is a graph of a function. Now let us come here. Now, is this graph of a function? No. Why? Because there are some lines which cut the graph more than once, right? Okay. So therefore, there are some lines which are parallel to y-axis which cut the graph more than once. So therefore, this is not a function. Is it clear for you? So if you find a line parallel to y-axis, okay, parallel to y-axis means it is having one single x-coordinate. If you find a line parallel to y-axis which is cutting the graph more than once, okay, then that will not be a function. Let me show you one more example. Let us say we will take the graph like this, okay, like this. So at x is equal to a, okay, this y coordinate is b, this y coordinate is c. Now, if you are taking a line parallel to y-axis, come from the left side. Always do it like this, it will be easy. Come from the left side. Now, leftmost place, okay, it is cutting only once, it is cutting only once, it is cutting only once, it is cutting only once. So therefore, this is a function. Now you come from left to right, a line parallel to y-axis. Always it is cutting only once. So therefore, this is also a function. You come here, it is not even cutting. No problem. No problem. Okay. So this x value is not there in our domain because there is no corresponding output. So therefore, this x value is not there in the domain. Let us not get into so much detail. If you're understanding, it is good. Or, there is nothing complicated here. This x value is not there in our domain. Okay. Fine. No problem. So therefore, there is no y value for it. Now you come here. As you go from left to right, is there a place where the line is cutting more than once? Yes, lot of places it is there. So therefore, this is not a function. Okay. Now you come here, it is not cutting, no problem. It is not cutting, no problem. It is not cutting, no problem. At x is equal to a, it is cutting twice. Okay. And how about the rest of the places? It is cutting only once. So till x is equal to a, it is never cutting. And at x is equal to a, it is cutting twice. After that, it is cutting only once, right? So therefore, now what is the meaning of this one? When you put when you have two dots like this means that at x is equal to a, y coordinate is b, and at x is equal to a, y coordinate is c as well. There are 2 points on the graph, okay, at x is equal to a, that is at y coordinate b and at y coordinate c, okay. So this is the graph. We have checked from left to right. At x is equal to a, it is cutting twice. So therefore, this is not a function. Just before we have studied in the definition of the function that every element of domain should have one and only one image. Every element of domain. Now, every element of domain means x is equal to a is there in the domain. For x is equal to a, there are some output values, right? So therefore, if you are taking the mapping diagram for this function, for x is equal to a, there are two output values, b and c. So therefore, this will not be a function. Of course, there are other values. Let us say, for example, whatever are the values of x, which are there after this. Let us say a1, a2, and so on like this. It just goes on till infinity. So let us remove the last one. So if you are taking all of the other x values, then for them, it is one single output itself. But at one place, it is having two outputs. So therefore, it is not a function. So that this is means we are seeing the same thing here graphically. At x is equal to a, we have two output values. So therefore, this is not a function. Okay. Even at least in one place, if you are having more than one output values, then it is not a function. Clear? Okay. So that is what we have understood, how to see the same definition graphically. Okay. So now we understood that there are graphs for which this does not represent a function. Let us take, for example, circle. We all know very well, right? Circle. Now, does this graph represent or denote graph of a function? No, because you can find a lot of horizontal lines which cut the graph more than once, right? So therefore, this does not represent a function's graph. Okay. Let us take, for example, a parabola. Okay. Now, does this represent graph of a function? No. Why? Because you come from left to right. You start from left and go towards right. Take a line parallel to y-axis. How many times is it cutting? It is not cutting. No problem. There is no problem at all. Now you come here at x is equal to 0. It is cutting only once. Next, as you go forward, it is always cutting more than once. Even if you find at least one place where it is cutting more than once, then it is not a function. Simple. Okay. And y also we have seen, because for one line which is parallel to y-axis, there will be one x coordinate. So if you find a line for one x coordinate, if it is cutting more than once, means it has more than one output values. So therefore, that will not be a function. Okay. So now we have understood what is a function. We have understood graphically how to check if it is a function or not. Next, let us take the next part, and that is the part of class 12, and that is types of functions. Now in types of functions, what will be there? There will be different types of functions. Now on what basis are you dividing, or you are saying that this is this type of function? Of course, there will be some specific property based on which you will say, okay, if this property is happening, then this will be called this function. If this property is not happening, then you will call this not that type of function. Something like this. The types of functions which you will be studying are onto function, next one function, bijective function, composite function, and inverse function. In all of these types, you will have some specific property. Let us say, for example, there is some property, okay? Let us say I will call this as property 1. Okay, there is one property called property 1. Now, if this property is, means if this function is following this property, then you will give a specific name. Let us say this property is for onto functions. Okay, so onto function. So because the function is following this property, you will give a specific name and say that it is an onto function. If a function is not following this property, then you will say it is not onto function. Simple. Okay, like that you will have different properties. This is another property. If the function is following that property, then you will give a name to it. Like types of relations. We have seen different types of relations. What are they? Empty relation, universal relation, reflexive relation. On what basis we named that this relation is, let us say, reflexive relation? On the basis that if a comma a belongs to R, for all a belonging to the set on which the relation is defined, isn't it? A comma a should belong to R. Every element of the set should be mapped to the same element. If that is happening, then that relation is given a specific name, right? Isn't it? So therefore, here also it is the same thing. You have a specific property, some property. If it is following, you will give a name like that. Okay. So these are the types of functions. These are for, CET, or these are for, boards as well. But for JEE, we will add two more, that is even and odd functions. And after this, we will discuss periodic and non-periodic functions. Okay, so these are the two extra things you will study if you are studying for IIT JEE. Other than that, after that, it will be the same things for IIT JEE as well. Okay, so these are the two extra things for IIT JEE. So now let us start the different types of functions.